Okay, so we continue, keep going down. You want 30 people total, right? Okay, so one person away. So the first person is here. Second person's right here, right? But notice the difference between the two is only one. Third person, if you take 365, take away 363, it's 2. So when I want the 30th person, I want to subtract, right? So 365 take away 30, which would be 335. But I want to add 1 to it, so it makes 336 divided by 365. Right, and that's just how it's going to happen because, for example, 1, 2, 3. 3 right here is only 2 away. So 30 will be only 29 away. Okay? Now, I don't want to figure this out by hand. I mean, talk about a pain. So we're going to make Excel do it. And I'm going to actually jump the gun a little bit because the formula I'm going to use here is going to actually be something from section 5.5. But first of all, we can definitely find 365. 365 to the 30th power. That will be the denominator, right? It's a huge number. That's 7.39. See that? E plus 76. That's scientific notation. It means the decimal place is 76 places to the right. Right? Catch that? It's like 739,241, blah, 0, 70 zeros. And right then the decimal point. It's huge. All right, now I'm going to cheat just a little bit. There's something called a permutation, and it's going to allow us to do that numerator because I don't feel like typing it out. I mean, you could type it out, 365 times 364 times 3, blah, blah. But what a pain. So the way to do it with Excel is to type equals permute, P-E-R-M-U-T. You say, I want you to take from 365, and I want you to take 30. And that will actually automatically figure out 365 times 364 times 363 times 362 and so on. Jumping the gun a little bit because that's something we actually do in 5.5 if we go to 5.5. And so that equals that divided by that. Boom. Catch that? Because these are both really big numbers. So when they divided them, they actually, all the 76 decimal places sort of canceled out. And I have them reversed, really. It's this guy is the denominator, and this one's the numerator. So let me just put them in order so you can see it a little bit better. Okay? So then this gives you the probability. So the probability that they're all different is only 29.37%. Did you catch that? So what's the chances that at least one of them, or excuse me, 2 of them have the same birthday? That would be, equals 1 minus that, which is 70.6%. So just think about that. The next time you're in a room with 30 people, when you're in a room with 30 people, any room of 30 people, the chances of at least 2 of them having the same birthday is 70.63%. Amazing, isn't it? And if you're wondering, what's the halfway point? It's around 22, 23. So you need about 23 people in a room for it to be about 50-50 chance that at least 2 of them have the same birthday. So even just 30 people in a class, there's a 70% chance that at least 2 of them have the same birthday. Really high. Very high. All right, so that's that problem, a birthday problem. All right, next. Conditional probability and independence. Okay. So if 2 events are independent, then their conditional probabilities will end up being equivalent. So, for example, not equivalent, but equivalent to the probability of E. So the probability of E given F is equal to the probability of E if they're independent, or equivalently, the probability of F given E is equal to the probability of F. So let's verify independence of dice by using the formulas. C is the event, red die comes up 1. D is the event, white die comes up by 1. What's the probability of C given D? Well, that's 1/6, right? Which is the same as it would have been no matter what, right? So the probability that a red die comes up, given that a white die came up 1, doesn't matter that the white die came up 1. It's still equal to the probability that the red die came up 1. Make sense? All right. So that's that. And then we'll start right here next time.